Here's a classic chart of exponential growth, a chart pattern that's often called a hockey stick for obvious reasons. At this point, it doesn't matter what's on the x or the y axis. What I want you to notice first is the shape. The only requirement for a graph to end up looking like this is that the thing being measured grows by some percentage each increment of time. The slower the percentage rate of growth, the greater the length of time we'd need to chart in order to see this hockey stick shape. In this particular case, you are looking at a chart of something that's only growing just a little more than 1% a year. It's world population, and because it's only growing at 1% per year, we need to look at several thousands of years to detect this hockey stick shape. The green is history, and the red is the most recent UN projection of population growth over the next 42 years. Clearly, human population growth has reached the near vertical phase of an exponential curve. The second thing I want you to take away from this chart is that once an exponential function turns the corner and begins to accelerate, even though the percentage rate of growth remains constant and possibly quite low, the length of time between each new increment added grows shorter and shorter. Here's what I mean. If we started with 1 million people on the face of the earth and set the growth rate to a measly 1% a year, we'd find that it would take 694 years before we achieved our first billion people. But we'd be at 2 billion people after only 100 more years, while the third billion would require just 41 more, then 29 years, then 22, and only 18 years to add another billion to bring us to 6 billion. That is, each additional incremental billion people took a shorter and shorter amount of time to achieve. Such is the tricky, devious nature of compounding. This next chart is of oil consumption, which has been growing at the much faster rate of nearly 3% per year. So we can detect the hockey stick shape over the course of just 150 years. And here's the U.S. money supply, which has been compounding at incredible rates ranging between 5 and 18% per year most recently. So this chart only needs a few decades for us to see the hockey stick effect. And here's carbon dioxide, also a hockey stick. And here's the world you live in. If everything seems like it's going faster and faster, well, that's because they are. You happen to live at a time when hundreds of individual graphs are all approaching the vertical phase of their exponential trajectory. And behind all of this, driving every bit of every graph, is the number of people on the surface of the planet. Taken one at a time, any one of these charts could command the full attention of every earnest person on the face of the planet. But we need to understand that many of them are in fact related and interconnected. All of these are compound graphs, and they are all being driven by compounding forces. To try and solve one, you need to understand how it relates to the other ones you see, as well as others not displayed here, because of the fact that they intersect and they overlap and they interrelate. The fact that you live at the apex of multiple exponential graphs relating to everything from money to population to species extinction has powerful implications for your life and the lives of those who will follow you. It deserves your very highest attention. Now let's move on to an example that I hope will help you understand these graphs just a little bit better.